Hello everyone. Myself Dr. Girisha D, working as assistant professor in Department of Plant Pathology, School of Agriculture, SR University, Warangal, Telangana. Today we are going to discuss about important diseases of rice and their management. Rice is a very important crop, belong to family Poaceae. Its scientific name is Oryza sativa. Though it is highly associated with wet humid climate, but it is not with a throat. It's not a tropical plant. Rice is an important staple food crop for more than 60% of the world population. India stands in second position after China with respect to production. The world estimated rice production is about 496 million metric ton with an area of 158 million hectares. India is the largest rice growing country, accounting for about one third of the world acreage under the crop. India's annual rice production is about 103.6 million ton with an area of 44.5 million hectares. Let's see list of important fungal and bacterial diseases. First, coming to fungal disease, blast of rice caused by Pericleria griseae, brown leaf spot caused by Elementhosporium oryza, sheath blight caused by Rhizoctonia solani, stem rot caused by Sclerotium oryza, foot rot of rice caused by Fusarium moniliforme, false smut of paddy caused by Eustollogenidia virens, Udbata disease of rice caused by Epilis oryzae. Coming to bacterial disease, bacterial blight of paddy caused by Xanthomonas oryza, Pethover oryza, bacterial leaf streak caused by Xanthomonas oryza, Pethover oryzicola. Coming to viral disease, rice tungro disease and grassy stunt of rice. Coming to important nematode disease, rice white tip nematode caused by Apellincoides besi, rice root knot nematode, Meridogena graminicola, Ufra disease of rice, Ditelinchus angustus. And some important physiological disorder is Thyroid disease of rice. Then we'll see what are the etiology, symptoms, and management of blast of rice. The first blast of rice is caused by the fungus Pericleria griseae. Disease is more severe in high rainfall areas, area which receives more nitrogen fertilizer. Application of more amount of nitrogen fertilizer will make plants sensitive to pest and disease. It will attract more number of pest and disease. It occurs in more than 80 countries in the world. In India, it is first reported from Tanjore district of Tamil Nadu in 1918. So it will cause loss with an extent of 70 to 80%. The loss is calculated by the following formula. It is calculated by percent of the panicle affected in the cropland. Let's coming to symptoms. The disease can infect paddy at all the growth stages and all aerial parts of the plant, including leaf region, neck region, and node region. Among the three, leaves and neck infection are more sensitive. The first symptom is formation of spindle-shaped spots, small specks originate on the leaves, which are enlarged into form a spindle shape, which are about 0.5 to 1.5 centimeter in length and 0.3 to 0.5 centimeter in width, with a ashy gray center. These several spots, these spindle-shaped spots coalesce together to give like a irregular patches. Then finally, the plant look like blighted in appearance. Coming to important symptom, first one is leaf blast. Among leaf blast, it will cause severe case of infection. It will give burnt or blasted appearance to the crop plant. Hence, it is known as blast. In severe cases, it may cause lodging of the crop plant after ear emergence. Coming to another important symptom, neck blast. So on the neck region of the or at the panicle region, there is a development of spindle-shaped spots. There is a collision of these parts and give like a completely or partially filled grains with a choppy grain. Then there is a breaking of the panicle at the point of contact between neck and panicle. Then the panicle will form hangs down. Then coming to another symptom, node blast. The infected node become blacks and break up. Here we can clearly observe the symptoms of leaf blast, formation of spindle-shaped spots. Then node blast at the node region, there is a blackish color discoloration of the nodes. Then finally neck blast. So among these symptoms, neck blast can cause more illness. Next, coming to pathogen, this fungi are reported to produce three-celled pyriform shaped conidia with a conidiophore. These are look like a pear shape or pyriform shape. Then coming to disease cycle, here the primary source of inoculum is infected seeds. The infected seeds, the farmers use infected seeds for sowing. These will going to infect the young seedling and appearance of the symptom. Then again the infected plant will produce these three-celled pyriform shaped conidia. Again, these are carried by wind along the wind direction. Then again they will infect the healthy plant, and there is appearance of again leaf blast, node blast, and neck blast symptom. So this is about brief disease cycle. Just coming to epidemiology, the plant of rice are very susceptible at seedling stage. rapid tillering stage, and ear emergence stage. Condition conducive for rice blast include long period of free moisture where leaf wetness is required for infection. Excessive application of nitrogen fertilizer favor the disease, and it requires a climatic condition of minimum night temperature with a range of 20 to 26 degrees Celsius along with a relative humidity of more than 90%. For 1 week, then the plant becomes susceptible and there is a chances of outbreak of the paddy blast. Condition that favors the disease development are sowing of disease seeds, poor airflow, poor sunlight penetration, and rainy days with a high humidity. Let's come into what are the important management strategies of rice blast. First is avoid excessive nitrogen application because application of more amount of nitrogen will make plant sensitive to pest and disease. Then application of nitrogen in split doses, one at basal dose and another at seedling stage. Then remove weeds, that is nothing but a clean cultivation, cleaning of bunds. Then use of some tolerant varieties like Penna, Pinakina, Tikana, then Palguna and Swarnamukhi, then CO47, IR64, IR636, and Jaya rice varieties. Then burning of straw and stubble after the harvest, and also going for dry seed treatment with Pseudomonas fluorescens. It's a biocontrol agent at the rate of 10 gram per kg of seeds. Then again seed treatment with 2 gram per kg of seeds with a Captana, carbendazim, or Thiram or tricyclazole. Then again spraying with Pseudomonas fluorescens, stock-based formulation at the rate of 0.5% from 45 days after transplanting at 10 days interval. Spraying of again tricyclazole at the rate of 1 gram per liter of water or edifenophos or carbendazim at 1 gram per liter at 15 days interval. Let's see another important disease, brown leaf spot. This brown leaf spot is caused by Elementhosporium oryza. The disease is very common in rice growing area. It will cause epiphytic form in Bengal famine. You know, the historical Bengal famine during 1942. Millions of people died due to brown leaf spot, only single disease of rice. The disease is soil and seed borne. The disease seeds show poor germination and there is a reduction in germination percentage. It will cause yield loss of 50 to 90% during extreme cases. Let's see occurrence of brown spot of rice. It is also called as sesame leaf spot or elementhosporiosis or fungal blight, mostly seen in West Bengal, Orissa, Andhra Pradesh, and Tamil Nadu areas. Let's come to symptoms occur in nursery as well as main field. Causes blight of seedling in nursery. Then leaf spotting is very common. Formation of irregular eye-shaped spots look like a seeds of sesame. That's why it's known as sesame leaf spot. The spot measures up to 0.5 to 2 mm in width, coalesce to form a larger patches. Finally, it gives like a blighted appearance to the rice plant. So these are the important major symptoms of brown leaf spot. So here we can see formation of sesame seeds like spots, like eye-shaped spots on the leaves, and there is a discoloration, brown discoloration of the infected seeds. Here the seeds are also infected, formation of black or brown spots on the glumes of the florets, and also which are covered by volvaceous velvety growth of the fungus. Infection also occurs on a panicle neck with a brown color appearance. There is a 50% yield reduction in the severe case of infection. Let's see about the pathogen. Here the pathogen produces about 7 to 8 cellulose conidia, and the sexual stage of the fungus is reported to produce perithecia, which is perithecia bearing ascospore inside the peritheum. So this is about the conidia and peritheum which contain ascospore. Let's coming to disease cycle. Here the disease cycle is divided into primary and secondary cycle. Let's coming to primary cycle. You know the infected seeds. When the panicle is infected by the fungus, then it will cause seed infection. The infected seeds will cause a primary source of infection. So first, when we sow the infected seeds, there is a germination of conidia and the activation of mycelium. Then there is a host infection to all the parts. Then there is a production of conidiophore. Then this conidiophore will produce lot of conidia. Then again, this conidia continues the secondary life cycle through wind-borne spore. Again, there is a infection of the conidia through infected fluorescence or panicle region. Again, that will cause seed infection that will continue the disease cycle of brown leaf spot. Let's coming to epidemiology. The disease occurrence was favored in a drier environment where reduced amount of water was present. Humidity level of the leaves and low minimum temperature for the crop cultivation favors the epidemics of brown spot. Optimal temperature for the pathogen is about 28 degrees Celsius. If the soil minerals such as nitrogen, potassium, phosphorus, silicon, and manganese are deficient, then there is a more incidence of this disease. Brown spot of rice is favored in areas where water level is low in the soil. Let's coming to important management practices. Use of disease-free seeds. Then since seeds soaked or seed treatment with Captan or Thyram at the rate of 2 gram per kg of seeds. Then spraying with a mancozeb, edifenophos at the rate of 2 gram per liter or 2 to 3 times in a 10 to 15 days interval. The spray preferably during early hours during the morning hours or afternoon at the flowering and post-flowering stages because the mainly infection occurs during flowering stage. Coming to another disease, sheath blight. Sheath blight is caused by the fungus Rhizoctonia solani. Rice sheath blight is an increasing concern for rice production. Yield loss of 25% was reported in flag leaves which are infected. In United States, yield loss of 50% was reported with a susceptible cultivar. Sheath blight has also caused yield loss of 6% in tropical Asia. Mainly, we can see the incidence of sheath blight in submerged rice. Let's coming to symptoms. Initial lesion, which are water soaked to greenish gray, and later they will become grayish white with a brown margin. Then lesion on the leaf sheath near the water line because the submerged condition only, these floating sclerotia, which will cause infection to the leaves which are touching the water flow. Then the lesion which may coalesce, causing death of the whole leaves. Then there is appearance of water soaked irregular patches of the fungal infection, they which may cause partially filled or empty or choppy grains due to lack of nutrition to the growing panicle. So these are the main symptoms of sheath blight of rice. We can see the submerged rice, it is infected by fungus Rhizoctonia solani. There is the appearance of irregular water-soaked greenish patches. Later they will turn into straw-colored appearance. Let's coming to pathogen Rhizoctonia solani. Its telomorph is known as Thanatophorus cucumaris. Rhizoctonia solani frequently exists at the thread-like growth on the plants in culture. There is formation of whitish mycelial growth, and it is a soil-borne pathogen. The pathogen is not currently known to produce any asexual spore, though it is considered to have an asexual life cycle. Then this pathogen mainly produce macrosclerotia, which are brown mustard seed-like very odd structure, which can survive in the soil for 6 to 7 years. The one of the main characters of this fungus is to produce right angle branched mycelium. Let's coming to disease cycle. You know the disease mainly caused in submerged rice. So when the floating sclerotia, which will infect to the submerged condition in rice plant, it will cause infection to the leaves which are touching the water flow. Then there is a infection by young sclerotia. There is germination of sclerotia. Then there is a infection, formation of green irregular patches. Again, the fungus get entry into the host plant. Again, it will produce the sclerotia. Then it will produce the right angle branched mycelium. Then this mycelium will spread inside the host plant. And again, there is a production of sclerotia that will continue the life cycle for 3 to 7 years. Let's come into favorable condition. Sheath blight occurs in areas with a high temperature of 28 to 32 degrees Celsius with a high level of nitrogen fertilizer, relative humidity, and crop canopy with a 85 to 100%. The plants are more vulnerable to sheath blight during the rainy season. High seeding rate or close planting, dense canopy, which are all favors the infection, and also presence of sclerotia in the water. These floating sclerotia, which will infect to the leaves which are submerged in the water and which will lead to reduced yield loss. Let's coming to management practices. Application of farmyard manure at the rate of 12.5 ton per hectare or application of green manure at the rate of 6.25 ton per hectare to promote antagonistic microflora in the soil. Then soil application of Pseudomonas fluorescens at the rate of 2.5 kg per hectare mixed with 50 kg of FOM after 30 days after planting. Foliar spraying with Pseudomonas fluorescens at the rate of 0.2% at boot leaf stage is recommended at 10 days interval. Avoiding flow of irrigation water from infected to healthy field because this floating sclerotia, it will cause infection to the healthy fields also. That's why I need to avoid the irrigation flow from infected to healthy plant. Application of carbendazim propiconazole. The spray is recommended at the rate of 1 ml per liter. Spraying the infected plant with a fungicide such as Venomil, Iprodin, and along with POC plus some antibiotics like Pelidomycin, Casidomycin, and Polyoxy, which are effective against this disease. Reduce nitrogen doses and skip the top dressing if recommended to manage the disease. Then coming to another important disease, false smut of paddy. This false smut of paddy is caused by the fungus Eustulaginaria virens. The disease affects early flowering stage of the rice crop when the over is destroyed. The second stage of infection occurs when the spikelet nearly reaches maturity. Mainly this disease cause infection to the plant when there is a flowering stage. These cause chalkiness in the grains, which can reduce about 1000 grain weight also. It causes reduction in seed germination up to 35%. The disease can cause severe yield loss, which may reach up to 25%. In India, yield losses are reported from 7 to 75% based on the infection rate. So coming to major symptoms, early the individual ears in the individual ovaries are transformed into large velvety green masses of spore ball. These are round to oval, attain a size of more than 10 millimeter. Only few spikelets in the whole panicle are infected. Glumes are not infected but covered by a thin silvery membrane. Color changes when it is exposed by breaking of this membrane that will release the spores of Eustulaginaria virens. Let's coming to pathogen. The pathogen reported to produce chlamydospore, which are formed on a spore ball, which are spherical to elliptical, warty volvaceous with measures up to 3 to 5 into 4 to 6 micrometer. Young spores are smaller, which pale in color, almost smooth appearance. Some of the green spore ball develop 1 to 4 sclerotia in the center. These sclerotia overwinter in the field. In the temperate region, the fungus survives in the winter by means of sclerotia as well as chlamydospore. It is believed that the primary infection are initiated mainly by ascospore, which are present inside the sclerotia. Mainly the sclerotia which contain perithecium. Inside perithecium, we can observe ascospore. The chlamydospore play an important role in secondary infection, which is a major part of the disease cycle. So this is the disease cycle. Here we can see the individual glumes or individual seeds are infected by Eustulaginaria virus. Then it will form black mass of spore ball, which contain chlamydospore and ascospore. Then chlamydospore as a source of secondary infection. Then infected seed which contains sclerotia. Then which contain ascospore serves as a primary source of infection. Then coming to management, use of disease-free seeds that are selected from healthy crop. Seed treatment with carbendazim at the rate of 2 gram per kg of seeds, and control of insect pests that make vulnerable to this disease. Split application of nitrogen is recommended. Removal and proper disposal of infected plant debris. Spraying copper oxychloride at the rate of 2.5 gram per liter, or propiconazole at the rate of 1 ml per liter at boot leaf or milky stages of the crop, which will be more useful to prevent the fungal infection. At a tillering and flea-framing stages, spray hexaconazole at the rate of 1 ml per liter or spraying with the chlorothalonil at 2 gram per liter.